Hello, this is Bunton with your Visual Functional Mathematics at Level 2, and this is Lesson 2 of your Data Handling series. And today's lesson will deal with using averages and range and grouped data. In this lesson, you'll learn that averages and range can be used to compare sets of data. Averages can be used to make estimates. Ordinary frequency tables of data can be grouped into classes, and you can estimate the mean of grouped data. So you note that we're dealing mostly with data. But one of the things you've got to remember, when you're handling data, you could be handling hundreds, sometimes thousands, and in some statistical department, millions of data on individual entities. You need to be able to manipulate them to get sensible results to help people make decisions about so many things. And this is why it's important to understand data handling well. The keywords you'll come across are averages, estimates, range, data sets, group, frequency, table, and mean. It's important that we know the meanings of these terms and that we use them correctly. So we start with using averages and range. Averages and range can be used to compare sets of data. You can use averages and the range in real-life example to compare data. Example 1, Joe and Annette want to book a hotel. They have found some reviews online for 2 hotels. Each category has been scored out of 5. Let's see what they say about the hotels. We have 2 hotels, Wellbridge Hotels and Old Mill Hotel. And these are the data. You have 5 reviews at the top, and then you have 3 areas that they're reviewing. Location, the service, the quality of service, and of course the standards of the rooms for both hotels. And the data for each of those reviews on the 3 categories are listed there, ranging from 4, 3, 2. In fact, you have 3 5s and quite a few 4s, 3s and 2s. So what does these data mean? That's what we're trying to find out. And the answer will tell us which of the 2 hotels has a better review. So the solution, which hotel has the better review? There's more than one way to answer the question, but you need to use the information in the table to support any answer you give. For example, you could work out the mean score for the location, service, and rooms for each hotel and then compare them. As you see there, you see location, you see service, you see rooms. Wellbridge, 3.4 for location, Old Mill, 4.4. Services, 3.4 for Wellbridge and Old Mill, 4.2. And then rooms, service, both hotels score 3. From these means, the Old Mill Hotel looks like it has the better review. You could use one of the other averages instead. For example, you could work out the median, and you can work out or compare the other averages we've learnt about. But it's important to make sure you use the correct average when you're working out some of these reviews. Using averages and range. The range can be used to show how varied or consistent the data is. If a set of data has a large range, then the greatest and smallest values are really far apart. This means that the data is spread out and not really very consistent. For example, the table below shows practice laps of a set of drivers in seconds. You have Smithson, Oliver and Durango on the table below, and each driver did 5 practice laps, and those are their times. Smithson, lap 1, 54, up to lap 5, 52, 53, 55 and 51 seconds. Oliver, 49, 56, 55, 57 and 53 seconds. And Durango, 51, 54, 56, 55 and 52 seconds. So how do we compare who has made very good progress? To answer this, you can use the range of times the driver has set. A small range of lap time for a driver means the times are all quite similar, so they are consistent. A large range means that the driver's time are not really very consistent. Smithson's range is 55 seconds minus 51 seconds, which is 4 seconds. That's the largest and the shortest time. Olivier's range is 57 seconds minus 49 seconds, which is 8 seconds. And then Durango is 56 seconds minus 51 seconds, which is 5 seconds. So on the basis of that, you can see which one is more consistent or which is most consistent than the other, which is Smithson's. So he's made some very good progress. Practice question set 1. Jen wants to go on holiday with her husband. The table below shows prices from 4 different travel companies: Flywell, City Halls, Destination City and City Escape. You have 3-day packages, you have 4-day packages, and those are their figures. Destination has figures for only 3-day packages. That means they don't have a 4-day package. A. What is the range and mean cost of a 3-day package from the 4 companies? B. Destination City don't offer 4-day packages, as I told you. What is the range and mean cost of a 4-day package from the other 3 companies? And then C. Jen thinks that Flywell offers cheaper holidays than City Escape. Is she right? And then D. Are the prices more consistent of 3-day packages or 4-day packages? Explain how you know. So all you have to do, you're playing with figures, finding range, finding mode, right? And then finding averages, mean. And then you'll be able to tell your answers or make decisions. The answers to practice questions set 1. Question 1. A. The range is £118 and the mean is £554. B. The range is £95 and the mean is £680. And then question C. The answer is yes. On average, Flywell is cheaper than City Escapes. The mean price of a Flywell holiday is £607.50. This is less than the mean price of City Escape, which is £645. And for question D, the prices are more consistent for 4-day packages. You know this because the range is smaller. We move on to the use of averages to make estimates. You can use an average to make predictions. For example, if you know a monthly average, then you can use it to predict values for a whole year. This is used mostly in financial budgeting in some banks and other businesses, but you can use it for other purposes as well. To do this, you assume that every month has the average value. Then multiply the average by the total number of months in a year, so you could multiply by 12. To continue with the example, Haida is late for work 3 times in November, 2 times in December, and 8 times in January, and 5 times in February. Work out the median and use this to find an estimate for the number of times that Haida will be late in 1 year. Work out the median by first putting the data in order. Remember again, putting the data in order. The median is halfway between 3 and 5, so it has to be 4. Now, assume that Haida is late 4 times each month. So to have an estimate for how many times she's going to be late for the year, you simply multiply 4 by 12 months, and that will be 48 times. Your estimate is unlikely to be exactly the same as the true value. Anything could happen. She could fall ill, or maybe she could feel better, or maybe she could have got a car which she drives and is taking her to work earlier. But you have to base your estimates on something, and this is where data handling estimates comes in. Okay, so all you have to do is to make sure that you use the proper method and your estimation is fair. In the example above, you assume that Haida will always be late 4 times a month. This probably won't be quite true. For example, she might be late more in winter because of the weather. But using the average should balance out the difference or the differences between the months. Practice question set 2. Joanne is the manager of a shop with 75 employees. She is looking at how long her employees have taken off work as holidays so far this year. She chooses 7 employees at random and writes down how many hours of holiday each of them has taken. Remember, she chooses the employees at random because sometimes when you sector them and choose specific employees, your estimation could be biased. Okay, so the holidays taken are 144, 117, 112, 92, 150, 51, and 75 hours. So, question A. Use the mean number of hours of holiday for these employees to estimate the total number of hours of holidays taken so far this year by all of Joanne's employees. B. Each employee is allowed to take 150 hours of holiday. Use the median of the numbers above to estimate the total number of hours left to be taken by all of Joanne's employees. So you're using a set of random data to make group decisions, or to make decisions about a whole group of people. Answer to practice question set 1. Question 1A, 7,950 hours. Question 1B, 2,850 hours. We now look at grouped frequency tables. Grouped frequency tables are like ordinary frequency tables, but they group data into classes. Classes do not overlap. If you look at the arrow pointing under number of pets, the grouping is at from 0 to 2, 3 to 5, 6 to 8, 9 to 11. There is no overlap. Overlap means if you look at 0 to 2, you cannot start 2 to 5, that will be an overlap. You start for the next logical number. And the frequencies, that is the figures for each group. So 0 to 2 is 9, 3 to 5, 3, 6 to 8, 2, and 9 to 11 is 1. In this table, no one has more than 11 pets. If you didn't know the greatest number, the last class should say something like 9 or more, or about 9 or more. And if you look under frequency, the frequency column tells you how many. For example, 9 people have between 0 and 2 pets. So it's a broad estimation, but it gives you a sensible guideline as to how to go about working with numbers. Estimating the mean for grouped data. 1. When you have a grouped frequency table, you can work out an estimate of the mean of the data. Secondly, because the data is grouped, you don't know what the individual data values actually are. That's why the mean that you calculate is only an estimate. To work out an estimate for the mean, first of all, add 2 extra columns to the table, and these might already in an exam be done for you in the exam. If you look at the arrows there, the additional columns are the midpoints and the frequency midpoint. That is where you multiply the midpoint by the frequency. Okay? For example, the midpoint of 0 to 2 is the number halfway between 0 and 2, which is 1. Thirdly, work out frequency times midpoint and write these in your second column, as you've seen there. For the first class, frequency times midpoint is equal to 9 times 1, which is equal to 9. So watch that. You're always given the number of pets, you're given the frequency. And you can see the grouping, that the classes are not, there is no overlap. The frequency are the numbers you have to work on. Then, to group them, you have to find the midpoint, and then you multiply the midpoint by the frequency. So work out the total frequency and the total frequency times midpoint by adding the column. You'll see the formula at the bottom there in the yellow box. The estimate for the mean is equal to total frequency times midpoint divided by total frequency. The mean is equal to 45 divided by 15. If you look at the total of the frequency and the frequency midpoint at the bottom of the table there, so you divide 45 by 15 and you have 3 pets as the mean. Practice question, set 3, question 1. Stanley records the age of everyone in his snooker club in the table below. Age is classed as follows: 14 to 18, then 19 to 23, then 24 to 28, and then 29 to 33, 34 to 38, and those are the frequencies, the number of people that are there. Find an estimate for the mean age of the people in the snooker club. You can use the empty columns in the table to help you. You should give your answers to the nearest whole number. What would be the headings for the extra 2 columns? Think about it, we just deal with it. And then once you've done that, then you can multiply that by the frequency to give you the midpoint. Question 2. The table below shows information about the number of calendars sold on a calendar stall each month last year. And those are the figures. Number of calendars 0 to 14, 6, 15 to 29, 1, 30 to 44, 0, 45 to 59, 2, 60 to 74, 3, and 75 to 89, 0. Work out an estimate of the average number of calendars sold each month. And the answer to practice question set 3. Question 1, 24 years. Question 2, 30.75 calendars. And that's our lesson, but before we go, let's check what we have learned. You have learned that averages and range can be used to compare sets of data. You've also learned that average can be used to make estimates. You've learned that ordinary frequency table of data can be grouped into classes and they should not overlap. And then you have learned that you can estimate the mean of grouped data. Again, I remind you, please attempt all the practice questions without looking at the answers. I've provided the answer just to enable you to self-assess yourself and check on your progress, because there wouldn't be anybody to do that for you except if you're attending college and you're using my materials for revision. So self-assess properly. Attempt the question, read the materials I've given you, attempt all the questions, then check your answer. If you have them all correct, fantastic. Celebrate by giving yourself a pat on the shoulder or on the back. If you didn't, it's no big deal. Just find out where you went wrong and do your correction. Remember, most of you will be preparing for an exam, so you have to prepare properly. And the only way you can do that is to make sure you are hard on yourself by following my advice. Okay? So that's the end of our lesson. 2 more to go, and then we're through. So I'll see you next week for lesson 3 on section 3 of data handling. Until then, take care of yourselves, and thank you.